Welcome, my dear students, in Prep 3. Today we will start the first lesson in trigonometry. In this session, we will discuss the main trigonometrical ratios of the acute angle. This is part 1, and we still have part 2 for this lesson. At the beginning, I want you to know that we have units for measuring angles. We studied before in primary stage the degree. We know, all of us know that the unit of measuring angles is degree. Today we will study two more units, which are minutes and seconds. So we have 3 units of measuring angles: degree, minutes, and second. We can convert from degree to minute and from minute to second by the relation that we know that 1 degree is 60 minutes and 1 minute is 60 seconds, like hour and second and minutes. Okay, so 1 degree is 3600 seconds. Sometimes I want to write the angle as a degree only, even if it's a decimal. And sometimes I want it as degree, minutes, and second. We can convert it using our calculator. Let's take an exercise to know how to convert. For example, 25 degrees, 36 minutes and 49 seconds. I want to convert it into degrees only. This question, write in degrees 25 degree, 36 minutes and 49 seconds. We can use the calculator as the following. At first, I write the first number 25, 2 and 5 on the calculator. Then I'll press the button of degree. Then I write 36. Then I'll press it again. Then I write 49 and press the button of degrees again. Then press equal and finally the degree button. Okay, use your calculator and try to do it yourself. The result will be 25.6136 and 4 ones. Okay, this is in degree only, without minute or second. Okay, also vice versa, we can convert, write in degrees, minutes, and seconds. So here I want to write this number is in degree. I want it in degree, minutes, and second by using my calculator. What can I do? I can write it 56.18. So I write 56, 5 and 6, then point, then 1 and 8. Then I press equal and the degree button. In this case, I'll get 56 degrees, 10 minutes and 48 seconds. You can do it for any number you want. Choose any number of degrees and try with a decimal, okay, a decimal number. Then try to convert it into minutes and seconds and degrees. Okay, so we have degree, minute, seconds, units for measuring angles, and we can convert between them. Okay, I want you to remember that the summation of two complementary angles is 90 degrees. If you have any two complementary angles, you studied before in Prep 1, that if the angles, okay, the summation of two complementary angles is 90 degrees. So if the two angles are complementary, the summation is 90 degrees. Also, if the two angles are supplementary, the summation will be 180 degrees. Okay, so any two complementary angles, the summation 90. Any two supplementary angles, the summation 180. Okay, this is a very important to know that. Okay, we have an exercise here. If the ratio between the measure of two supplementary, what do we mean by supplementary angles? The summation is 180. Okay, so they are two supplementary angles. It means the summation is 180 degrees. Okay, the ratio between them 5 to 11. Find the degree measure of each of them. I want the measure of each of them. What can I do? Do you remember ratios in primary 6? Okay, let's do it again. And if you didn't understand, you can revise the video of ratios between two numbers. Okay, let's begin. Here we have the ratio is 5 to 11. So I'll assume the first one is angle 1 and angle 2. The ratio is 5 to 11. Here I have the summation because I know that the two angles are supplementary. So I know the summation is 180. So I'll add the ratios. 5 plus 11 is 16. Then I write here the real numbers. I don't know the real measure of angle 1. I don't know the real measure of angle 2, but I know the summation is 180. Now I can use the cross product to get angle 1 and angle 2. How can I get angle 1? Do you remember? Angle 1 will be 180 times 5, then divided 16. Okay, this is angle 1. It will be 180 times 5, then divide 16. What about angle 2? By the same way, 180 times 11, then over 16. So I get the two angles here will be, the first one will be 56.25 and the second will be 123. What about if you want to check your answer? You should add the two angles and the summation should be 180 because they are supplementary angles. Okay? Okay, let's continue. Do you remember Pythagoras Theorem? It's very important to know how to get a missing side length in a right angle triangle. Here, for example, we have a right angle triangle ABC. If you want to get the hypotenuse, what should we do? I'll take the square root of the square of the summation of the two sides. So if I want the hypotenuse here is AC. The hypotenuse is AC. If you want to get AC, you will take the square root of AB power 2 plus BC power 2. Okay? The hypotenuse is the longest side in a right angle triangle. If you want to get the hypotenuse and you know the two other sides, just take the square root of the summation of the squares of each side. What about if I want another side, for example AB? If I want AB, I'll take the square root also, but here of the difference between the squares of the two sides, the hypotenuse and the other side. For example, I want AB equals the square root of hypotenuse, which is AC power 2 minus BC power 2. What about if I want BC? If I want BC, it will be the hypotenuse power 2 minus AB power 2, and don't forget to take the square root. So if you want to get the length of the hypotenuse, you will take the square root of the summation of squares of the two other sides. If you want any sides except the hypotenuse, you will take the square root of the difference between the squares of the length of two sides. Okay, we'll study also a trigonometrical ratio of an acute angle, the ratio between side length in a right angle triangle. It's the ratio between the side length in a right angle triangle in which this angle is in the right angle triangle. For example, if I want angle theta, for example, this symbol read as theta. Okay, so this is angle theta. If I want the sine of this angle, I can get it from the right angle triangle here, and I can get the cosine and the tangent of this angle. We have three rules, one for sine the angle, and one for the cosine, and the other for tan. The sine of any angle theta is the opposite over hypotenuse. This is angle theta. What is the opposite of angle theta? The side, and this is the hypotenuse. So to get the sine of this angle, I'll divide the length of the opposite side over the length of hypotenuse. What about if I want cosine theta? Cosine theta equals adjacent over hypotenuse. So I'll divide the length of the adjacent side over the hypotenuse. If I want the tangent of this angle theta, I'll divide opposite over adjacent. and it's the same as sine theta over cosine theta. Okay, so now I have three rules. Sine theta equals opposite over hypotenuse, cosine adjacent over hypotenuse, and tan opposite over adjacent, or sine theta over cosine theta. The opposite and adjacent is according to the angle I want to get this ratio for. Okay, if I want to get the ratio for this angle, so this is opposite, this is adjacent, and of course this is the hypotenuse. If this angle, in this case, the opposite will be this side and this side will be the adjacent. Okay, let's take an exercise. Here I have a right angle triangle ABC. It's a right angle triangle at A. AB 9 centimeters, AC 12, and BC 15 centimeters. I want number 1. Find sine, cosine, and tan for the two angles B and C. Okay, let's start with number 1. I want to get sine B. Let's remember together, sine any angle equals opposite over hypotenuse. What is the hypotenuse? Hypotenuse is 15. So at first, this is the hypotenuse. Okay, now I'm talking about angle B. This is angle B. What is the opposite of angle B? This side, which is 12. And what is the hypotenuse is 15. So sine B will be 12 over 15. Then I'll simplify it by dividing by 3. So it will be 4 over 5. So sine B will be the opposite of angle B over the hypotenuse. It will be 12 over 15, which is 4 over 5. Okay, also angle B, but in this case I want cosine B. Cosine B equals adjacent over hypotenuse. The hypotenuse is 15. Adjacent is 9. So 9 over 15. Then I'll simplify it. It will be 3 over 5. What about tan angle B? Tan is opposite over adjacent. So 12 over 9. This is the opposite side for angle B, and this is the adjacent. So 12 over 9. Then I'll divide by 4. It will be, I'll divide by 3. It will be 4 over 3. Okay, so I have the three ratios for angle B. I have sine, cosine, and tan B. Now let's go to angle C. So I find sine B, cosine B, and tan B. Now I want sine C, cosine C, and tan C. Let's begin. By the same way, the sine C will be opposite over hypotenuse. The hypotenuse is 15. Where is the opposite of angle C? This is angle C. So the opposite here is 9. So 9 over 15. 9 over 15 by dividing by 3, it will be 3 over 5. So this is sine C. Okay, what about cosine C? Cosine any angle equals adjacent over hypotenuse. The adjacent for this angle is 12. So 12 over 15, which is 4 over 5. Let's move to the tangent. Tan angle C. Tan means opposite over adjacent. What is the opposite of angle C? 9. What is the adjacent? 12. So 9 over 12. 9 over 12 is 3 over 4. Okay? Okay, what can you notice here? At first, angle B and angle C are two complementary angles. Why? Because the summation of these two angles should be 90. We have a right angle triangle. This angle is the right angle, so 90. So we have another 90 degrees in this triangle, which is the summation of the two angles C and B. If the summation of the two angles is 90, so I have two complementary angles. Okay, I can notice here the sine of angle B. Look at here, the sine of angle B is the same as the cosine of angle C. Is that clear? And also, the cosine of angle B equals the sine of angle C. And this is a property for any two complementary angles. Okay, so for any two complementary angles, sine angle A equals cosine B, and sine angle B equals cosine angle A. Okay, this is a rule can be applied for any two complementary angles. Okay, number 2 in the same exercise, prove that sine b cosine c plus cosine b sine c equals 1. I want to prove that sine b times cosine c plus cosine b times sine c equals 1. Okay, I substitute in this equation. The left hand side will be sine b cosine c plus cosine b sine c. I'll calculate it. If the answer is 1, so we have proved the required. Okay, here we have sine b is 4 over 5 times cosine c is 3 over 4. Okay, also cosine b is 3 over 5 and sine c is 3 over 5. So again, sine b is 4 over 5, cosine c also 4 over 5, cosine b 3 over 5 and sine c 3 over 5. Okay, let's multiply. 4 times 4 16 and 5 times 5 25. So we have 16 over 25, and here 3 times 3 9 and here 25, so 9 over 25. So we have 16 over 25 plus 9 over 25, which is 25 over 25. If you want to add two rational numbers, the same denominator, so I write the same denominator, which is 25. Then I'll add 16 plus 9, 21. 25. 16 plus 9, 25. 25 over 25 is 1. And this is the right hand side. Okay, so we proved that sine b cosine c plus cosine b sine c equals 1. Again, we studied today 2 more units for measuring angles, minutes and degree. We studied how to convert from degrees to degree, minute and second, and vice versa. We studied 3 trigonometrical ratios, which are sine, cosine, and tan, which is tangent. We said that sine any angle equals the opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tan equals opposite over adjacent or sine over cosine. That's all about our session today. We will continue the main trigonometrical ratios of the acute angle next session. I hope you have understood our session today. See you next session, and thank you very much. Goodbye.